Right now, Earth feels stable, predictable, and permanently locked into its orbit around the Sun, moving through space in a way that seems perfectly balanced and unchanging. But imagine a moment when something massive enters the solar system, something invisible at first, something that does not shine, does not emit light, but bends everything around it, a black hole. At first, nothing looks different. There is no explosion, no immediate destruction, no dramatic signal that something has changed, because black holes do not announce themselves. They distort space, not in a way that can be easily seen at a distance, but in a way that begins subtly, affecting motion long before it becomes visible. As the black hole approaches, the first noticeable change is in gravity. Earth's orbit begins to shift, not suddenly, but in a way that becomes increasingly unstable. The balance between the Sun's gravity and Earth's motion is disrupted, and instead of following its usual path, Earth begins to drift. Days pass, and the shift becomes impossible to ignore. The position of the Sun in the sky changes slightly, seasons begin to lose their pattern, and astronomical observations reveal that something massive is influencing the entire solar system. Planets no longer move exactly as expected, and trajectories begin to curve in ways that cannot be explained by anything known within the system. Then, the sky begins to change. A region appears where stars seem distorted, stretched, and bent around an invisible center. This is gravitational lensing, the bending of light around the black hole, creating a warped view of the universe that signals the presence of something extremely dense and powerful. As Earth is pulled closer, the effects intensify. The planet accelerates, not because of propulsion, but because space itself is curved in a way that directs motion toward the black hole. The closer Earth gets, the stronger the pull becomes, and the faster everything moves. Time itself begins to behave differently. From an external perspective, clocks on Earth appear to slow down as the planet approaches the black hole, a result of gravitational time dilation predicted by relativity. To those on Earth, however, time feels normal, even as the outside universe appears to speed up. The Sun begins to distort in the sky, not because it is changing, but because the path of its light is being bent. Its shape stretches, curves, and shifts in ways that defy normal perception, turning a familiar object into something unrecognizable. Tidal forces start to build. These forces, caused by the difference in gravity between one side of Earth and the other, begin to stretch the planet. At first, the effect is subtle, but as the distance decreases, the difference becomes extreme. Oceans begin to shift, pulled unevenly, creating massive tides that do not follow normal patterns. The crust of the planet experiences stress, and geological activity increases as the structure of Earth is subjected to forces it was never meant to endure. As the black hole grows larger in the sky, it does not appear as a solid object, but as a dark sphere surrounded by a glowing ring of distorted light, the result of matter and radiation being bent around it. This is the event horizon, the boundary beyond which nothing can escape. Approaching this boundary, the most extreme effect begins: spaghettification. The difference in gravitational pull between the side of Earth closer to the black hole and the side farther away becomes so large that the planet begins to stretch. Not metaphorically, but physically, as matter is pulled into a long, thin shape. This is no longer a gradual process. It accelerates rapidly, and within moments, the structure of the planet can no longer hold itself together. And still, from the perspective of someone far away, Earth appears to slow down, freezing at the edge of the event horizon, never quite crossing it. But from Earth's perspective there is no pause. Only acceleration toward the inevitable. As Earth crosses the event horizon, there is no visible boundary, no line in space marking the transition, only a continuation of the fall into a region where the rules of physics, as normally understood, begin to break down. From the outside, the planet appears frozen at the edge, fading slowly, but from within, everything continues forward. The tidal forces that began outside the event horizon intensify beyond anything imaginable. The difference in gravitational pull across even small distances becomes enormous, stretching matter further and further. At this stage, the structure of Earth has already been compromised, and what remains is no longer a cohesive planet, but a stream of material being pulled inward. Time behaves in ways that no longer match intuition. From the perspective of anything falling into the black hole, events continue in sequence, but the outside universe appears to accelerate dramatically. Light from distant stars shifts, and the entire observable universe seems compressed into a smaller region of the sky. Radiation becomes increasingly intense. Matter falling into the black hole forms an accretion disk, heating to extreme temperatures and emitting powerful radiation. As Earth's remnants move through this environment, they are exposed to energies far beyond anything experienced in normal space. Deeper inside, the concept of direction loses meaning. All paths lead inward, and there is no trajectory that allows escape. The geometry of space itself is curved in such a way that moving forward always means moving closer to the center. At the core of the black hole lies the singularity, a point where density becomes infinite and current physical theories can no longer describe conditions accurately. What happens at this point is unknown, not because it is hidden, but because the laws that govern it are not yet fully understood. From the outside, the story appears incomplete. Earth never seems to fully cross the event horizon, instead fading slowly, its light redshifted and stretched until it disappears. To an observer far away, the process takes an infinite amount of time. But from within, the end comes quickly. There is no infinite delay, no eternal pause, only a finite progression toward the center, where the structure of matter is pushed beyond any recognizable state. In the aftermath, the black hole remains unchanged in any noticeable way. Its mass increases slightly, incorporating what was once an entire planet, but on the scale of such an object, even a planet is a small addition. The solar system, however, is no longer the same. With Earth gone and the gravitational balance disrupted, the remaining planets continue to move under the influence of the black hole, their orbits altered, their futures uncertain. This scenario reveals something fundamental about black holes. They are not just destructive objects, but regions of space where the limits of physics are tested. They reshape motion, alter time, and challenge understanding at every level. And perhaps the most unsettling part is not the destruction itself, but how quietly it begins. No explosion, no warning, only a gradual shift that leads, inevitably, to a point from which nothing can return.